This is Mira. So I'm going to be your ICSE topic teacher today. Okay. So let's see what to learn in computer science today. Okay. I hope that you guys are having your tests or exams near, so you wanted to prepare and get good marks in your computer exam. Okay. So I have all the lessons. I'm going to prepare like all the lessons right from the first unit to last unit, and then after when I'm done with these lessons, we're going to see the expected questions and most expected questions and most important questions in future. Okay, so make sure that you follow me and you also subscribe to the channel so that you might get all the recordings to you and it could be easy for you. Okay, you might ask me what is objects, but we in the later the session, in the end of session, you might know what is object is, what is class is, what is abstraction, intelligence, polymorphism, and encapsulation is. Okay, so before saying what is object and stuff, let's go ahead and see what is the features of object-oriented programming language. Okay, the features are, I'm going to use a new slide. We're going to have a class, and the programming is going to divide by functions. We're going to have a function, and inside this function we have set of blocks. Okay, the set of a main code, body of the code, and again a function. And you know what happens, we're not exactly going to run this function. Okay, until we call this function or we use this function in a code, it's not going to exactly run it. Okay, in the first few 5 chapters we're not going to see about these functions, these objects. Okay, so only when we are in your 10th grade and when only when you're studying the class and the function chapters, the modules chapters, you're gonna look at this. Okay, until then we're not gonna clearly understand what is a function and what is a object. Class, you might know what is class, but till then you might not know like what is a function. You might get confused, or you might think it's not a major part of the book, or it's not a major part of the programming language, but it is a major part of programming language. Okay, until we use this you might not understand what it is. Okay, so in future you might get clear what is a object function is. Okay, so yes, so these are the features of object oriented programming. So I have 3 points, and this helps in solving the complex problem. Okay, this is easier to solve complex problem, because as you can see that we are dividing in, as you can see we are dividing into objects, number of objects. Okay, so as we're going to divide this in number of objects, if I am going to have any problem in some certain place, it is easy to find me and it is easy to solve a complex problem. Okay, rather than me having a whole bunch of code which looks like this, I could have a code which looks like this. Okay, so what happens is, this is not a code, I'm just showing the differentiation. Okay, so let's say you are writing in a paragraph, and a paragraph looks like this, and you're not sure. Let's say you got a mistake and you're not sure where you need to check. Okay, when it looks like this, but when it looks like this, you know. Okay, so let's say you have some certain code here, and code here, and these codes are not same code, they have different properties. Okay, let's say this is to find sum of a number, this is to find a multiplication of number, and this is to find division of number. Okay, so the when I say like the open and close bracket, it means that let's say this one is a math function, like whole math function, and this is a class math. Okay, so when I have this open and close bracket, it means that it is a function. Okay, so function has some set of properties under this. Okay, it's going to have something like a plus b, c is equal to a plus b, so print c, something like this. Okay, which helps me to run the code. Okay, so let's say when I'm running the code, I have a problem in multiplication. Okay, my output is not multiplying. So what happens, I could easily come to this part and check, okay, I think I might gone wrong with this multiplication part, right? I could easily do this. But when it comes to this example, it is not easy, right? I have like one class which is called math, or a function which is called math, and I'm not pretty sure where I should check. Okay, whereas in this example I can clearly see I'm not going to disturb my sum and I'm not going to disturb my divide. Okay, I'm just going to come over my multiplication and check, okay, what problem do I have over here? And that is in simple the object oriented programming language. Okay, okay, so next Okay, so let's see this definition. So okay, now we don't need this. So this depends only on data. Okay, it does not depend on the functions. Okay, this depends only on data. Okay, and what happens is okay, yes, so object oriented is the main function is it is a model approach which depends only on data rather than function. Okay, and then let's see an example. I think we could see example here. Let's say object A, and it has data and a function, and similarly object B, data and function. And let's say we have a object C, data. Okay, so the data depends on function, obviously. Okay, so okay, so the data is going to be inside the function. Okay, that's why the arrow says. So these two have a communication. Okay, and what happens is the object A is dependent on object B. Okay, as you see in this code, only object A can handle its function and the data. Okay, so only object A have the like full access to only object A will have the full access to access the its object, its function and data. Okay, whereas in object B it can handle only its data and its function. Okay, it cannot handle the object A's data. Okay, and in object C same, it can only handle the object C's function data. Okay, so why do we have this is a powerful tool, so that we don't have to like go ahead and access the next object. Okay, it helps in protection of data and it makes the data secure. Okay, so this is the another property and example of object oriented programming language. It does not allow the data to move freely. Okay, so it can only this one object A can be accessed only the object A's data, it cannot access the object B's data. Okay, so what happens is as I said, it does not allow, that's what the meaning says, it does not allow to access freely, allow data to go freely. Okay, and this is another point, protection and security. Okay, as you can see, the object C cannot access the object A. Okay, the functional data of object C cannot be accessed in object A. So what happens? We don't have any loss of data. We don't have any. We would have a protection over the data. We would have security over the data. Okay, and let's see the main question. The main topic. This syllabus is a procedural oriented programming language, that is POP, versus, oh my god, and OOP. Okay, OOP is object-oriented programming language and POP is procedural-oriented programming language. Okay, this is one of the important question they might ask in the exam. Okay, so listen carefully. In this, it is oriented on procedure. Okay, so what happens is the stress is put on function rather than data. Stress is on functions rather than data, whereas in this stress is on data, as I showed you in last example. In this example, as you can see, what happens here is we didn't say the function. Okay, so we are talking about the data and protection of data, security of data. Okay, so we didn't say, oh, what happens if the function get lost. Okay, so what happens the object B access the object A function. We are talking about the data. Okay, all the stress is on data rather than the function. Okay, we don't care about the function in object oriented, whereas in POP it's different. The stress is on function. The functions is more important than data. Okay, So data can freely flow. So as I showed you an example like this, okay, this is going to be pop and this is going to be the oop. Okay, so if let's say sum can be accessed only in this part, multiplication it can be accessed only in this part, okay, whereas this is a math and it flows wholly, okay, the data is going to flow from year till year, okay, whereas in this the data is going to flow from year till year for sum, and for multiplication it's gonna flow over here till here, and the variables over here cannot be accessed over here, okay, and same happens to a division, okay. Yes, so that's what said data can freely flow, whereas it cannot, data is restricted and cannot be freely flown. Restricted and restricted and is the next point is going to be access specifiers. So access specifiers is the public, private, and protected. Okay, this is called access specifier. No access specifier. We have access specifier in OOP. Like as you can see, public void, static void when we say that, right? So this is a public. So public can be when we say this public static void main, which means that public anybody can see, okay. When I say instead of public, when I say protected, it just means only specific person can access this page, okay, they access the class. When I say private, only the person who can handle is the person from the same place, okay. So these are the public, private, and protected access specifiers, okay. So have access specifier like public, private, protected. And lastly, we have it is a top to down programming language. This is a down to top programming approach. Down to top or bottom to up. So in this example, let's check this example. So what happens is when the cursor is decoding the compiler, okay, when it compiles, what happens is it's going to see from top and it goes in this direction, okay. Whereas in we have at the end of this, I think we have the as you might know that at the end we have a main function, and everything starts with this main function, okay. So it's going to start from down. So usually we have a main function at the end of this end of the class. At the end of all we are done with the functions, we're going to write our main function, and the program actually starts running from here, okay, from bottom to up, okay. So let's say I've called my sum over here. So what happens is it goes from here and now it goes up and runs my sum, and then let's say I have said my multiply, I call my multiplication, then it goes over and checks for multiplication and runs whatever is inside the multiplication, okay. So the procedure is going to go from bottom to up. Okay, I think we took so long for the introduction. Okay, so we are done with this. Okay, so now let's see the principles of object-oriented programming. They are simple, easy, and I'm gonna give you examples with it. Okay, so they are kind of very easy. You don't have to stress on that. Okay, before going into the principles, we need to see what is class and object. Okay. Okay guys, so let's see what is classes, okay. Class is nothing but representation of objects, okay. Representing all the objects is going to be class, okay. uh, this one is a class, okay. This place is going to be a class, okay. So it's going to be class, and let's say class map, and this is how my class is going to look, okay. So this is a class. So why I'm calling you classes, okay. Did you see this? This is a blueprint and this is a template of all the programming, okay. I'm going to do all my programming stuff inside my class. Okay, all the objects are going to be inside the class. Okay, I'll be creating my object over here. Okay, let's say I want to create an object for this class. I'm going to say the class name is going to be math. Let's say object name is equal to obj, and new class, like the new class name. Okay, this is creating an object. Okay, now I can call object of sum. Okay, call it. What happens is now it's going to run. Okay, now I have created the object. So the class holds all the object inside itself. Okay, so that's called representation of object. It's representing the object. Okay, that's the first point. And the next point in class is, as I said, it's a blueprint of plan or template that describes the details of an object. Okay, it's going to okay, let's say what does the detail of object means is, as you can see, I have said, okay, object dot sum, open and close bracket. It means I'm calling my object, it goes over here and checks what's inside my sum. Okay, let's say c is equal to a plus b and print c. Okay, so this is inside the sum. Okay, so what's happening is it's defining the sum in detail. Okay, this is called defining the sum in detail. Okay, defining the sum function in detail. Okay, that's called that's what this explanation means, this sentence means. Okay, it's going to details of the object, it's going to describe the details of an object in detail. Okay, and as you can see, and this is going to be the syntax. This is going to be syntax to create a object. Okay, so first we need our class name. As I said, over here the math is my class name, so I have my class. Okay, let's create this. Math is my class name. Okay, and object name, so you can give any object. I'm going to give obj. Okay, or oa, you can give anything in the object name. This is your definition. Okay, and then say new keyword, use a new keyword. Okay, and then say math, the class name again, open and close bracket and semicolon. Okay, you might ask me what is this new keyword is. Okay, this keyword helps me in allocating a space. Okay, so allocate space. So when I say new math, it's going to create me a space in my compiler, in my cursor, in my backend, and it helps me to run the code. Okay, and that's why we use the new keyword. Okay, so let's see some real-time example of class. This the first example is going to be my classroom. Okay, let's take a traditional classroom. Okay, so what happens in a traditional classroom? A traditional classroom consists of students, teacher, tables, benches, books, etc., etc. Right? Books, table, pencils, whiteboard, blackboard, and cupboard. We have a lot of stuff in a classroom, right? So all of these is going to be each class. Okay, I mean all of this is going to be an object. Okay, so every one of this, the table, books, bench, everything is correlated. The whiteboard, the blackboard, everything is correlated, and everything is going to be an object. Okay, let's take the classroom. So the classroom is going to be the class. Okay, the classroom is class, and all the objects inside the classroom, including the teacher and the humans as well, I'm going to call it as an object. Okay, everything inside the class is going to be a classroom, is going to be an object. Okay, so because of why it is, because the student have a specific role in their life in the classroom, inside the classroom. The teacher has a specific role inside the classroom. The table has a specific role. The books have a specific role inside the classroom, right? So what happens is all of them are inside the class. Okay, so what happens is, so all of them together, what happens is all of them together make a set of rules. They have a set of protocols to be followed inside the classroom or inside the school, right? So they all helps in building a academic curriculum. They helps in building the running the academic curriculum smoothly, right? So that's the purpose of this classroom, the traditional classroom and the students. Okay, that's your purpose of the traditional classroom and students. Okay, same way we can create in the programming language life, we can create a class, and with this class we can create a object with each of it. Like I'm creating a function teacher and table function, books function. Okay, I can create the function and call them. Okay, so everything can be object in the programming language. Okay, next, as you can see, like let's go ahead with the objects. Okay, before going to objects, let's see another real-time example. Let's say we have a class fruits. Okay, to go ahead and write over here. So let's say we have a class fruits, and under fruits, let's say we have apple. The object 1 can be apple. Object 2 is going to be bananas. Object 3 is going to be grapes. And object 4 is going to be muskmellow. Okay. So all of these falls under fruits. Okay, they have the same properties as fruits, like they're going to be sweet, and each one has its own color, each one have its own property, the nutrients, each one have its own. Okay, so as you can see, the class is fruits, and each one of it's going to be the object, and they have their own function, and they have their own stuff to work in the programming language and in real life too. Okay, this is another real time example. And yes, and let's now go with objects. And what is an object? Can you guys have any idea from all the explanation that I gave? Do you have guys have any idea what can be object is? The definition of object could be, it's simple, right? The object. Okay. So object is nothing which has its own properties, characteristics, attribute, data, function is going to be an object. Okay, which has its own characteristics, behavior, as we said, talked about the classroom. And inside class, student have its own functions. They have their own characteristics and behavior inside the classroom. The teacher has their own characteristics and behavior inside the classroom. The table have its own characteristics and behavior inside the classroom, right? So same way, object, okay, not the same way, that is called object. Okay, they have their function, they have their purpose to perform some certain task inside the object, inside the classroom. Okay, classroom or class. Okay, so that's going to be an object in simple, and they are unique. Okay, everything is going to be unique, and nothing is going to be repeated, or nothing is going to be a waste of code, a waste of line. Okay, so everything is going to be unique entity which that contains it and function together in a OOP language. Okay, that's the object, and the examples of object you can take it from the last thing. Okay, let's consider the real world objects which are visible before us. Any object in the real world can possess the following features: it is visible, it can be defined and described easily, it can put into thought and action. Okay, and then let's see another example, and let's say consider a table. Okay, the table has the following characteristics, that is, it has a 4 legs, it has a plain top, and it possesses a follower behavior, like it is used to keep the books, it's used to keep the classes, it used to keep the water bottle, it used to keep the water bottle upon it. Okay, not kept, keep water bottle upon it, right? So these are the characteristics of a table. Okay, so these characteristics and behavior of the table, right? So these are can be in detail, we can say these are the objects. You might get very clear when we start coding. Okay, you might find it confusing right now, but let's if you're clear, then it's great, else it's fine. Okay, so next we need to see the definition of object and class. Let's see the differentiation of object and class. Over here it's going to be object, and over here it's going to be class. Okay, so first, it is, as we saw in this example, it's a real-time representation of some unique entity having some characters and behavior of its own. Okay, so unique, it's the same thing. Okay, guys. So these are going to be some definition, some examples of, the differentiation between the object and class. Okay. The first, as we know, object has its unique entity. Okay, and which contains its data and function together in OOP. Okay, it has some unique characteristics of behavior. Whereas in class, it's going to be representation of abstraction only. It is a representation of blueprint only, the overview only, right? So it is used by creating a new operator. Whereas object. In class we produce object, right? So in class it is called as object producer because it is a blueprint of object. Okay, so it doesn't create anything, it creates object. We create object inside the class and it holds all the objects together. Okay, so this is called object producer and this is called object factory as well. And because it holds all the object together in the code, we call it as a object factory, whereas this is called instance of class. So instance of class, because where each object is created from a class, okay, called, that's why it is called instance of class. Okay, so because every object is inside the class and that's why we call it the instance of class. Okay, so for example, let's take an example of, let's say, Doberman. Okay, and this is going to be a function or an object. Okay, there's going to be an object inside the class called dog. Okay, the class is dog and inside this we're going to have some breed called Doberman. Okay, so what did we understand from this code? It means we have a thing called dog, class called dog, and under this we have a subset which is called Doberman. Okay, and that's why in simple we call it as class and object. Okay, so now let's quickly go ahead and with the encapsulation. Okay, I think I'll use a new slide. Encapsulation, nothing but wrapping of data and function in single unit is going to be encapsulation. Okay, let's take example like a capsule. What do we see in capsule? Okay, the inside the capsule or tablet, the tablet which looks like a capsule. Okay, what happens inside that capsule? We have some very important properties which is going to heal our health, right? Same way, it is why do we have in the format of capsule? Because if let's say the person gave the medicine in a powder way, in a powder format, what happens is the strength, the all the nutrients of nutrients and all healing properties of the tablet is going to vanish in the thin hair, right? Same way, that's why it is wrapped together in a capsule way and it is given to us and is wrapped inside the tablet cover and it is given to us. Okay, why don't they just give like in loosely, oh, have this, open your mouth, I'm going to throw this inside your mouth? Why don't they do that? Because obviously if they're going to do that, it's going to lose all its properties and it's going to be in paste, right? That's why we have encapsulation. Same in programming language, we have encapsulation which helps in wrapping of unit and functions, wrapping of data and functions in single unit. Okay, so another example is, let's take a mobile phone. Okay, let's say what happens if the shopkeeper gives the phone, like that he's giving the touch screen in one in by one person is giving touch screen and another person is giving the battery and another person giving the sim card and another person is giving the inner organs of the phone, another person is giving me the app. So what happens if it's everything is going to be separated? Okay, at the end of the day we all anyways don't know how to put all this together. Okay, so what happens is it's going to be a waste of money at the end of the day because we might not know how to put all these things together. We might get trouble by not by clicking or by pressing something and which goes wrong. Okay, so what happens is the shopkeeper, the person who's giving us the phone in the shop, gives us a whole which is in a great working way. So in a new condition he gives it that way, right? So that's the purpose of encapsulation. Okay, it's not giving one by one of, it's not giving like one thing in one hand and one other thing in another hand, right? He's giving the whole thing, the whole phone as one. Okay, and he's wrapping all the functions together, all the properties, all the mechanics, I don't know what to call the inside the sim cards, chips, everything he's wrapping and giving to us as a whole. He's not giving one by one. Same way we need to make sure that we are wrapping all the data in a single unit and giving it as a programming language. Okay, uh, that's the encapsulation. And next we have data abstraction. Okay, data abstraction is nothing but hiding of important details is going to be data abstraction. Okay, let's take the same example. Let's take the mobile phone. Let's say the person who's giving the mobile phone, the shopkeeper is giving all the important chips, like the important chips are outside. Okay, we can visibly see the chips, we can see the motherboard of the phone, the computer. What happens if we can see it and we can able to access the important details of the back end of the phone or the electronic device? What happens then? It can easily go to waste, right? It can easily get we can easily touch it and we can easily break it, and it might spoil at the end of the day. It's not, we're not sure, we might not sure if it's going to last long, right? So that is the purpose of hiding all the important details, right? So that's another example. So important details only showing the essential properties, that is essential properties on a mobile phone is like touching the home page, the accessing the home page and able to install the apps and stuff is going to be the very important properties of the phone. Okay, and same way, let's take another example, like let's say we have a driving a car. Okay, so for driving a car it is necessary only for you to know the accelerators, clutch and steering, brake, gears. Okay, that's all the important stuffs you need to know, right? You don't need to know more than that. Why? If you're going to know like more than that, like the back end of it's well and good if you know the back end of the car, but it is not necessary for you to know, okay, what the how the car is actually running and what all the processing happen in the car, and what it is good to know it, it's not a bad thing. But not everybody knows, not every person who drives a car like me doesn't know what happens inside the car. I just know how to press the clutch and how to press the accelerator and go ahead, right? So it is not necessary to know all the important details that is inside the car or anything. Okay, so only the important details, how to use a car is more than enough, how to use a phone is more than enough. I'm not going to go ahead and research anything behind it. Okay, so I'm going to write example car and phone. I don't have to take this session long, but I'm just speeding up the whole session. Okay, next we have inheritance. Okay, inheritance is something cool. I like inheritance. We always use the properties of inheritance in our programming languages. Okay, okay, let's say inheritance. Okay, inheritance, it is the process in which one class can link and share some common properties from objects of another class. Okay, so object of one class can link and share the properties of other class. Okay, let's say I have an object, let's say I have class, let's say I have class circle. Okay, let's say I have class square and class rectangle. Okay, so what are the properties we'll be using in this? We'll be having the same. Let's say I have my function, the object called length, breadth, height. This is what I will be having inside my square, right? And this, it's the same thing I'll be having my inside my length, inside my rectangle as well, and breadth, right? So what happens is I don't have to recreate two stuff. Okay, I can actually in the, I can, let's say, shapes, instead of having two classes called square and rectangle, I can have shapes, and I can just reuse this purpose. Okay, I can reuse this thing again and again. I don't have to create a new different two different classes, and I don't have to do that. Okay, another way is like I can get the properties of the length. Okay, let's say it even this has, the square has a length and breadth, but I know, okay, so it's going to be, the formulas are different, but I have length and breadth. Okay, let's say this, it's going to be twice this thing, right? So I can alter. Okay guys, so let's look at a better example for inheritance. Okay, so as you can see, a person can be a programmer, a dancer, a singer, right? So a person can be a programmer, dancer and singer. Okay, so same way, let's say a person has an abilities to learn, walk and eat. So it doesn't mean a programmer can't learn, walk and eat, right? So it means a programmer can also learn, walk and eat,
Dancer can also learn, walk and eat, and the singer has also the properties of learning, walking and eating, right? So this is inheritance, okay? This is going to be the parent class, and this is going to be, all these going to be the child class, okay? So the I want only the set of properties, okay? Because in detail, the programmer might work in a different company, the dancer might have a group, a different school, or he might go and join in a different school, and he might go and have a different band name, okay? But when it comes to a child, he also has the same abilities, okay? He also have the abilities to learn, walk and eat, right? So using some classes, so using some properties from a parent class into a child class, okay? So I don't need like all the classes that are in a person, like I don't need let's say for programming, we need other skills. In a person we have other skills like gossiping. So I don't need the gossip function in programming, dancing, dancer or singer. So same way, okay? So it doesn't mean like I need all my personalities to be a programmer. I do not need all my personalities to be a dancer. I just need to be good at dancing. Even if I'm not good at dancing, I can improve my ability to be a good dancer, right?
Next we have singer. Same way, it is not necessary for me to be a good singer. I should have a basic good voice, and I can, if with my practice I'm gonna get better anyways, okay? It is not necessary for me to be a gossiper, but I need to make sure that I'm doing the basic stuff to walk, learn, and to sing and talk, right? So these are the stuff, okay? So it is the inheritance. Let us revise again. What is inheritance? Is a process in which object of one class, so I can link some properties, I can take some common properties from parent class and give it to the child class, right? So sharing of common properties into child class, common properties from one class to other class, is simply known as the inheritance, okay? So let's next see the polymorphism. Polymorphism is nothing, so poly means available in it derived from biology, okay, which means available in many forms, okay? So poly is many, so polymorphism is nothing that available in many forms, and morphism is form, okay? So polymorphism is just means that available in many forms, okay? Excuse me. Okay, polymorphism is a process of using a function for more than one purpose, okay? So purpose of using more than one function is going to have given you the explanation of the definition of polymorphism, purpose of using a function more than one purpose, okay? So in this example you can see shape, okay? So the inheritance is, we can time saving and reusability, okay? And you can use a polymorphism same way, time saving and reusability, okay? We can reuse it how many times we wanted to. So let's say the shape, okay? Under shapes I have common object called area, okay, to finding an area. So when it comes to circle, I can use this area, okay? I can use this function in circle to finding a circle of an area. I can use the same area to finding a area of a triangle. I can use the same thing to find the area of a rectangle, right? So this is the simple example of polymorphism. And then we have, let's say next example, so let's say class animal. So animal can make sound, okay? So let's say a dog, class dog. Inside class dog, we know that a class a dog can even make sound. So okay, so I'm going to say even the dog can make sound, so I'm going to say make sound of dog, okay? And make sound of cat. So I have created only one class, and under that class is a common class which is animal, and that animal I'm giving all the common properties available in an animal, and then I'm using it in my code. So that what happens is I'm using it in my code so that I don't have to rewrite the code again. I don't have to like rewrite the whole thing again, and it's going to be time saving for me, okay? So that's the polymorphism, using one function or class in more than one way, okay, or in more than one purpose. Okay, so we can end the session for today. Okay, this is the first unit. We are done with all the concepts, and the important questions from this is going to be, okay, so they might ask the definitions of all these things. So they might ask, like, there's high chances of asking like what is abstraction, inheritance, and polymorphism. From this they can ask you one question, and like the principle, two principles of this. And in 2 marks they might give you definition and name the, they might name, oh, what this means, so what is wrapping of data, so what could be the answer, like, oh, choose or fill in the blanks. They probably not ask you choose, but in fill in the blanks. Okay, so the quick question, so what is a function which has parent and okay, what is the concept which has the parent and child class? This question is repeated. Okay, so the answer is, it's going to be the, what is that, inheritance. Okay, so they might ask like which helps in into hiding the essential features and hides the unnecessary details and shows you only the essential features that need to be shown. So it's going to be data abstraction. Okay, so they can ask you that type of questions. They can ask you what is the difference between object and class. They can ask like what does a class encapsulate. So a class this question has been asked in 2013. So what does a class encapsulate? A class encapsulates characteristics, behavior, data members, and characteristics and behaviors, that is data members and member methods. And they might ask difference between pop and oop. Then we have object factory. They can ask you what is the instance of a class is. An instance of class is important question, they have asked a lot of times. And yes, they might ask you what is the syntax of a class, like this, like I have shown in this current picture. And then yep, I think that's all, and we won't be getting any programming from this chapter. So yes, there is a like from this chapter there's a lot of definition question. So make sure I start in the definition question, and I'm going to give this slide. I'm going to give the notes in my description, so make sure you make use of it. Yes, until then, bye till we see in the next video. Bye bye.